Hi. In this video we'll be talking about the exponent laws. These are very important laws that help us simplify exponential expressions or expand them, in general to manipulate them so hopefully we can achieve a certain goal with them. Now, they're just general tools, so you'll have to figure out how to use them. Now, all these different exponent laws, all 8 of them, you don't need to memorize them per se, but you have to be able to use them without having to think about it too much. They should come naturally to you. Okay? So you want to practice and practice and practice till they are natural for you. All your math teachers after this will expect that you know them by heart. So let's take a look at them. We'll give some examples as we move along. Now, if we look at the first exponent law, it says that if you take any base and raise it to the exponent 0, well, any non-zero base and raise it to the exponent 0, you'll get 1. So for example, that means if you take pi and raise it to the 0, you'll get 1. If you take 10 and raise it to the 0, you'll get 1. If you take 7 and raise it to the 0, you'll get 1. And this matches with our graphs of exponential functions where we saw that they always have an intercept at 0, 1, no matter what the base was. The next one tells us how to deal with negative exponents. It says if you have a negative exponent, that corresponds to a reciprocal. Now, what does that mean? It means if I have, let's say, 5 to the negative 1, that would be a fifth. Or let's say I had 2/3 to the negative 1, then I would have the reciprocal of that, 3/2. Or let's say I had 2 to the negative 3, then I would get 1 over 2 to the positive 3, which is 1 over 8. So that's what a negative exponent means. It means we've got a reciprocal here. Now, what happens if we've got fractional exponents? Well, we've got roots then. So, for instance, if I write down 5 to the 3/2, that is the same as writing down the square root of 5 cubed, or that's the same as writing down the square root of 5 cubed. Okay? So we see that the denominator of our exponent tells us what root to take, okay? Whereas the numerator acts like a regular type exponent. Now these first 3 laws are really more just definitions. They just tell us how to handle a zero exponent, a negative exponent, or a fractional exponent. Now the other 5 laws are really properties. Okay, ways that we can simplify exponential expressions. So the first one says if you have 2 powers with the same base and you multiply them together, you get a new power that has the same base with the old exponents just added up to get the new one. So as an example, you might have 2 to the 5 times 2 to the 3, and that would give you 2 to the 5 plus 3, 2 to the 8. But this law works backwards as well. If I have a sum in the exponent, like say I've got 3 to the 2x plus 5, then I could rewrite that as 3 to the 2x times 3 to the 5. So that exponent law goes both ways. It's an equal sign, so both sides are equivalent, equal to each other. The fifth law says that if you divide 2 powers that have the same base, then your answer is going to be a power with that same base, but you take the exponent of the old top minus the exponent of the old bottom to get your new exponent. So if I take 2 to the 5 and I divide it by 2 to the 3, I get 2 to the 5 minus 3, I get 2 to the 2. But of course that works both ways as well. Let's say I've got 5 to the 2x minus 7. I could rewrite that if I wanted to as 5 to the 2x over 5 to the 7. Now the sixth law talks about if you have a power of a product, and it says that's equal to the product of powers. So if I have, say, 5x in brackets and I square it, then I can square each individual factor. 5 squared times x squared. But it goes the other way as well. Let's say that I have the product of two powers and they have the same exponent, like I've got x cubed times y cubed. I could rewrite that as xy all cubed. Now the seventh law talks about the power of a quotient. It's equal to the quotient of the powers. So if I've got 2/3 and I raise it to the exponent 5, I get 2 to the 5 over 3 to the 5. On the other hand, that law goes both ways. If I have a fraction with powers in top and bottom, let's say I've got a 3 to the 7 in the denominator, I could rewrite that as x over 3 all to the 7. And our final law talks about a power of a power. So if you have one power that's raised to a new exponent, well, you can write that as a single power, but you just end up with a product of the old exponents as your new exponent. So let's say I've got 5 to the x, and then I cube it. Well, that would be 5 to the 3x. On the other hand, if I already have a product in my exponent, like say I've got x to the 2 times 7, I could rewrite that as x squared to the exponent 7. So you can go both ways there. Now, again, please take a good long look and practice lots of examples of these exponent laws. You'll be expected to know them by heart and be able to use them at will. We'll do a bunch of examples in class, but before we get to that, I just want to, again, reiterate these ideas having to do with what to do with fractional and negative exponents. So let's say I've got a 4 to the 3/2, and I'd like to calculate that. How would I do that? Well, what I'd do is I would, for the exponent of 3/2, I could think of it as the square root of 4 cubed. That's our second exponent. Oh, sorry, it's our third exponent law. So we've got the root of 4 cubed. So what does that mean? We would square root 4. And then cube the result. Now there's another way to get the answer as well. You could cube 4 first and then square root the result. It's up to you which order you'd like to do them in. It doesn't matter. Okay. If we have a 5 to the negative 2, we know from law number 2 that's the same as 1 over 5 squared. So we would square the 5 first, and then take the reciprocal of the result. For the final example here, we've got 8 to the negative 5/3. Well, we know we're going to take a reciprocal, we're going to do a cube root, and we're going to raise it to the exponent 5. The order in which you do those doesn't matter as long as you do all of them exactly once. So let's, I don't know, cube root the 8 first. And then we could raise the result to the exponent 5. And finally, take the reciprocal. Okay, and that three-step process would allow us to compute 8 to the negative 5/3. Again, please spend plenty of time practicing these exponent laws. They can only be learned through extensive practice. Thank you.